Let's take a look at the final problems on that lab from yesterday where we went through and figured out the kinematic equations. Okay, just a little practice here. Number 2 says a car has an acceleration of 2 meters per second squared. If the car starts from rest and accelerates for 10 seconds, how far does it travel? Okay. Well, first thing we want to do is we want to establish a positive direction so that we know which way everything's moving. Okay. So I'm going to draw a little car sitting right here at rest, and it's going to start to accelerate in that direction. I just assigned that 2 meters per second squared. And I'm going to go ahead and I'm going to call that the positive direction. So now I know I'm going to find my variables. My acceleration is 2 meters per second, right? The car starts from rest. That's got some hidden value in it. Initial velocity is 0 meters per second. Accelerates for 10 seconds. That tells me a time is 10 seconds. And I want to know how far it travels. Okay, how far doesn't ask you where it ends up, it just means how far is it from where it started, and that's a displacement. Okay, so I'm given an acceleration, a time, an initial velocity, and I'm looking for a delta x. The first kinematic equation is out because it relates final velocity, initial velocity, acceleration, and time. The third one relates position, final velocity, initial velocity. I don't know final. But the second equation says x equals 1/2 at squared plus v naught t plus x naught. And if I can subtract that x naught over to the other side, I can say that delta x equals 1/2 at squared plus v naught t. Well, this is happy because my initial velocity is 0, so that term drops out. I'm just left with 1/2 2 10 squared. Super tricky problem. This is 100 meters. Okay. At the end of the interval, it'll be going 20 meters per second. It started at 0 meters per second. The average of 0 and 20 is 10. 10 meters per second for 10 seconds is 100 meters. So there's a couple ways you can do that. Kinematic equation's fine. How far would the car in problem 2 have traveled in 10 seconds if the initial velocity of the car had been 3 meters per second? Okay. This is where it's kind of nice to think of it like a graph, but we know as it accelerates, it travels 120 or 100 meters. Well, let's just work out the problem, and then I'll look at that. Okay, so acceleration is still 2 meters per second, but this time my initial velocity is 3 meters per second. My time is still 10, and I'm still looking for change in position. So I'm going to use the same equation. Change in position equals 1/2 at squared plus v naught t, but this time I have a v naught, so that doesn't drop out. So this equals 1/2 2 times 10 squared plus 3 times 10. This is still 100 meters plus 30. Okay, so this is like the original 30 I would have gone if I'd never accelerated, plus the 100 more I did go. So this is 130 meters total. Okay. Alright. And finally, number 4. A car traveling at 30 meters per second can be stopped by brakes in a distance of 60 meters. What is the acceleration of the car? Again, we need to draw a little picture so we know what's going on. I've got a car, and it's traveling this way at 30 meters per second. It's going to brake, which means it's going to accelerate this way at some acceleration. Don't know what it is. But this is my positive direction, so I know what's going on. Okay, it's going to travel to the right 60 meters because it is moving that direction. So what do I know? I know an initial velocity, a car traveling at 30 meters per second can be stopped, so I know final velocity. By the brakes in a distance of, I know a change in position, 60 meters. What is the acceleration of the car? Alright, so I know an initial velocity, no final velocity, and no change in position, and I'm looking for acceleration. Okay? Looking at all my equations, I know the last one says v squared equals v naught squared plus 2a delta x. Okay? And I know 3 out of the 4 of those, so I can say final velocity 0 squared equals initial velocity 30 squared plus twice the acceleration times the change in position. So now I have 900 plus 120a equals 0. Subtract over my 900 and I got 120a equals negative 900. Divide both sides by 120 and a equals negative 7.5 meters per second Does it make sense that the acceleration is negative? Absolutely. We're good to go.